Hello, welcome back to Math Success Seminar Online. I'm going to talk about exponents and how they work, what to look out for. Basically, you got this tiny number hanging out up top of this number. So we would call this number the base number, because this is really the important number. This one is called the exponent, or I could just do this, exponent. And what does that mean? Well, exponents is a special type of multiplication. Special mult. Basically, what this means is you're going to multiply 2 times itself 3 times. What does that look like? 2 times 2 times 2. And now you can work it out. You can go 2 times 2 is 4 times 2. What is 4 times 2? That's 8. So it is safe to say 2 to the third is 8. 2 to the 3 power, 2 to the third, any way you want to say it, as long as you take into account both numbers, and you know that this is the base and this is the exponent. So now on to negatives. What if it's negative 2 to the third power? So that means you're going to multiply negative 2 times itself 3 times. And this calls back to the previous video of, is the answer going to be positive or is the answer going to be negative? Well, how many negative signs do we have? 1, 2, 3. So that's an odd number of negatives, meaning before I even do the multiplication, I know our answer is going to be negative. So 2 times 2 times 2, we found out before, is 8. So the difference is this one becomes negative 8. So what's the difference between this, and I'm going to put is not equal, and this? Well, in this one, that 3 is taking into account everything that's inside of the parentheses, where here the 3 is only on this 2. So how can we expand this one? Well, we have this negative out front that we're not touching, but then this 2 is going to be multiplying itself 3 times. So you really want to pay attention to where the exponent is and what's inside of the thing the exponent is affecting. And then we know what 2 times 2 times 2 is. That's 8. Is that going to be positive or negative? Well, we have 1 negative, 2 positives. An odd number of negatives means negative 8. I'm not sure that the class goes as far as combination, but since 2 to the third power is 2 times 2 times 2, more rules for exponents and how to deal with the powers. If you have 2 to the 2 times 2 to the 1, how many 2's do you have? Well, here's 2 of them, here's 1 of them. So you actually have 3 2's. So these are different ways to write exponents, how they interact. Basically, if you have any number, let's use 3 this time. Let's say 3 to the 4 times 3 to the 4. How many 3's do you have? Well, we have 4 of them here, 4 of them here. So we actually have 8 overall. Just ways to combine and simplify before getting on to actually figuring out what 3 to the 8th is. I'm not going to do that right now. It's something huge. Another rule to worry about is anything to the 0 power. 2 to the 0 power, 3 to the 0 power, 75 to the 0 power. All of these are equal to 1. Equal to 1, equal to 1, equal to 1. So anything to the 0 power is automatically going to be 1. I'm not going to go too far into mentioning why, but since we're multiplying something, usually 1, by how many of what we have, so this would be like 2 times 2 times 2, this is telling us we have no 2's, but we have to have something, so there's a 1 there. We have no 3's, but there's a 1. We have no 75's, but there's a 1. trying to think how far this explanation goes. That's mainly the gist of it, is knowing how many negatives you have, knowing how many of each number you have, and they're going to fit these into much larger problems. Since I mentioned multiplication, I'm going to mention the two other ways of combining. So we have 2 to the third over 2. Whenever you're dividing bases, you're subtracting powers. Since this is in the numerator, it stays positive. This one's in the denominator, so that becomes negative. And notice this one doesn't have a little exponent on it, so you always assume it to be 1. 2 to the 3 minus 1 is really 2 to the 2, which is 2 times 2, which is 4. If we took this the other way, what if we expand this first? We know that's 8, and we're dividing 8 by 2, that becomes 4. So 2 different ways to get to the same answer, but this is how you can combine exponents. This is very useful when you have very large exponents, because if this was 2 to the 50 over 2 to the 35 or something, figuring out what large number this is and what large number that is, it's just easier to deal with the powers like this. The last form of combining and interaction with exponents, let's do 5, is when they're separated with parentheses. Anytime there's a parentheses like this really means multiplication. So this is 2 to the 2 times 5. 2 times 5 is 10, so this is 2 to the 10. I'm not going to carry that out on screen, but just to show kind of how it interacts. Or 3 to the 4th, and 3. So this would not be 3 to the 7, because there's no extra base for this 3. You can only add exponents when they have the same base. But since we have an exponent on an exponent, what this is saying is we're really multiplying 3 to the 4th 3 times. So that would be 3 to the 4th, 3 to the 4th, 3 to the 4th. How many 3's do we have? We have 12 of them. So you can also think of it as 3 to the 4 times 3. 3 to the 4 times 3, and that's also 3 to the 12th. So in sections very close to come, they're going to have you doing order of operations, and they're going to throw exponents in there. They're going to throw multiplication, addition, subtraction. There's going to be lots of negative signs. There's going to be division symbols, various types of multiplication symbols. So knowing the difference between all of them and knowing how each piece works is important for solving a problem. But I'll catch you next time.